exponential function, say e to the power x 1, e to the power x is given, so dy dx of basic rule of differentiation of e to the power x, we would get from here e to the power x. Same thing we would get from here. This actually we got from the first principle of the differentiation. This is our main rule of the exponential. Now we are going to discuss about few more example about the exponential. So it is given e to the power 5x. How to differentiate it? So as exponential, if we differentiate, we got from here e to the power 5x. Then from the top, it is not x given, 5x given, so we have to differentiate this 5x and we need to multiply. So you know from the basic differentiation, we got from here the 5 divided dx of 5x, it gives us 5. So our final result is 5 e to the power 5x. This is our answer of this part. Let's see another example. If it is written here e to the power 3 e to the power say minus 5x given, so what it would be? Similar procedure, we needed to multiply 3 as a constant, needed to write first, then e to the power the whatever the things are written there, we need to write the same thing. And if we differentiate on the top minus 5x, we got from here minus 5. So finally we can write here minus 15 e to the power minus 5x. We also can write it like this, minus 15 over e to the power 5x due to the reason of negative power. So this is our answer of this part. So let me move a few more examples. Say it is given here e to the power x square. How to differentiate it? So as we know, differentiation of the e to the power something means the whole thing you needed to write again. So e to the power x square, and on the top x square, if we differentiate, we needed to differentiate the x square according to the rule of chain rule, e to the power x square, and from there we got from here 2x. So our final answer is 2x e to the power x square. This is our answer of that part. Let me go for few more example. If it is written here x square minus 2x, what would we get from here? Same, e to the power x square minus 2x as a exponential differentiation, and on the top if we differentiate x square minus 2x, we go up from here twice x minus 2. Then finally you can write it by taking 2 common from this, the second part we can write it x minus 1, then the exponential part e to the power x square minus 2x. So that is our answer of this question. If it is given here 1 by e to the power 3x, say how to differentiate it? It's very simple. According to the indices rule, we need to arrange first by taking 3x e to the power 3x up by putting a negative power here. Then now we can differentiate as exponential. We got from here this. Then if we differentiate as a minus 3x, we got from here minus 3, negative 3. So our final answer we can write here minus 3 over e to the power 3x. So this is our answer of this question. Now I'm going to show a few more examples. Say if exponential function given as a product with the x, how to differentiate it? X e to the power x. So definitely we need to apply the product rule. If you don't know the product rule, then please see one of my video by clicking the top right I button. There is a product rule videos are there. Then you're able to understand from there. So dy dx of x, this is the rule for the product rule. We know I'm going to repeat the product rule. Say dy dx of uv given, then this is actually we needed to write u dv by dx plus v du by dx. This is the rule. Or we also can write u dv by dx, same thing, derivative of the v plus v into derivative of the u. This is the product rule. We are going to apply this one here. So x, and from ex we got ex, same thing, and from the right side only the ex we got because x d by dx of x, it gives us 1 only, so we can take x common, then the expression becomes x plus 1. So this is our final answer of that part. uh, let's move this given expression, given x square plus 1 and another function is given e to the power 5x. Both things are with the multiplied rule, so we needed to apply the product rule again, which is x square plus 1, then write here d by dx of e to the power 5x, then plus e to the power 5x d by dx of x square plus 1. So it's very simple now. Now let me write x square plus 1, and if we differentiate e to the power 5x, it gives us e to the power 5x into 5, because on the top it is written here 5, then plus e to the power 5x, from here you can write directly, and differentiation of x square plus 1, it gives us only 2x. So now write in a simplified form, which you can write, say 5 e to the power 5x, then on the inside the bracket it is x square plus 1, then it is plus 2x e to the power 5x. We can take e to the power 5x common from the whole term, then it would be e to the power 5x. If we take common, then it becomes 5x square plus 5 plus 2x, and we can leave our answer here. This is the general form of this equation. Let's go for the quotient rule, application of the quotient rule in the dy dx. So we are considering another term e to the power 3x, say, and it is division with the x plus 1 given. How to do that? We needed to apply here uv rule. Uv, you know the quotient rule of the uv, we have to apply this one here. V du by dx minus u dv by dx, derivative of v divided by v square. We also can write it v du by dx, same thing, minus u dv by dx, and on the denominator we can write it v square. So we are going to apply this formula here. Let me write the whole thing. V is x plus 1, let me write x plus 1, then d by dx of e to the power 3x minus e to the power 3x d by dx of x plus 1, and the denominator we need to write x plus 1 whole square. So just simplify it. On the top, if we differentiate, we got from here x plus 1, and differentiate of e to the power 3x, it gives us 3 to the power 3x minus e to the power 3x into, if we differentiate x plus 1, we got only the 1, okay, and on the below we needed to write x plus 1 whole square. So we can write in simplified form, which gives us, if we take e to the power 3x common, e to the power 3x common, on the top the part is remaining 3x plus 3, then minus 1, and the below it is x plus 1 whole square. So finally you can write from here e to the power 3x, on the inside the bracket it is 3x plus 2, and on the below it is x plus 1 whole square. This is our answer of this question. So I'm going to move one or two more questions to for you. Let's see another one. If the expression is written here e to the power 2x plus 1, and with the whole power is given, say 4, so it's very difficult to expand with the binomial. Rather than doing that, we can differentiate it directly. As a power, we are going to differentiate first. So 4 e to the power 2x plus 1. Then from the power, we are going to subtract 1, which gives us 3. Then into, just right on the right side, inside the bracket, if we differentiate, we got from there, which is e to the power 2x plus 1. So 4 e to the power 2x plus 1, and differentiate of e to the power 2x plus 1, we got from there 2 e to the power 2x. Now just write in the simplifying form, 4 to the 8 e to the power 2x, and inside the bracket you can write it e to the power twice x, 2x plus 1. So this is the answer of this expression. Let's move to the last example I prepared for you. Say e to the power 2x given, and on the below it is only written here x. How to differentiate it? You know the quotient rule. We are going to apply here the quotient rule, which is v du by dx, x d by dx of e to the power 2x minus e to the power 2x d by dx of x, and on the denominator we need to write x square. So let's differentiate x into 2 e to the power 2x minus e to the power 2x into 1, and on the below it is x square. So if we take e to the power 2x common from the top, then the remaining part is 2x minus 1, and on the below x square. So this is the total thing of the exponential. So we can make the equation longer, but this is the basic rule from the differentiation. Likewise, before I prepared one worksheet for you, which is completely about the exponential function, which already has been uploaded on the description below PDF, as a PDF. So you are welcome to download it for your practice, and please comments below. uh, comment